Okay, am I audible now?
Yes, sir.
Yes, sir.
Okay,
Yes, sir. Yes, sir.
thank you. So we'll start. Is my screen visible?
Yes, sir.
Yes, sir.
Okay. So let us quickly recall what we have seen yesterday. We are in successive differentiation, and in that we covered some problems based on nth derivative of standard function. Okay, we have studied uh, how to use partial fraction to get nth derivative of uh, 1 upon some polynomial function. Okay, or p of x upon q of x, where there are conditions on degree of p of x and degree of q of x. Okay, moving ahead uh, in successive differentiation, next is find nth derivative of 1 upon x square plus a square. Okay, so this is general. That means whatever proof we are going to take is in general. You may find some particular value to a. Accordingly, uh, proof goes on similar line. Okay, so y is equal to 1 upon x square plus a square. Right now we don't know its nth derivative, but what we know is we can factorize this x square plus a square. So the factors are x plus ai uh, and x minus ai. Okay, where I is imaginary iota. So if you do partial fraction, so a upon x plus ai plus b upon x minus ai, you will get a as 1 upon 2ia and b as minus 1 upon 2ia. Please do this partial fraction. A into x minus ai plus b into x plus ai is equal to 1, and find out a and b. Please do it immediately. A into x minus ai plus b into x plus ai is equal to 1. Then you substitute x is equal to ai, you will get b, and substitute x is equal to minus ai, you will get a.
Sir, please repeat once more.
A into x minus ai plus b into x plus ai is equal to 1. You find out those coefficient a and b by substituting x is equal to ai, and in the next stage x is equal to minus ai. Okay, and check whether you are getting a is equal to 1 upon 2 ai and b as minus 1 upon 2 ai.
Sir, A is equal to 1 and B is equal to minus 1. Just that we'll have to take 1 upon 2 IA as common.
Yeah, just let me know if you are getting same a and b.
Sir, A is minus 1 upon 2 AI, right?
Yeah. Correct. Yeah, I'm sorry, because x plus ai is here. So a is minus 1 upon 2 ai, right? And b is positive 1 upon 2 ai. Are you getting same? Other people?
Yes, sir.
Yes, sir.
Can you go ahead now?
Yes.
Can we go ahead? Yes. Can we go ahead?
Yes, sir.
Yes, sir.
All right. So once you have this y, we know that its nth derivative is this 1 upon 2ai is constant in multiplication. So it will be as it is. Nth derivative of 1 upon x minus ai is minus 1 raised to n into n factorial into a raised to n, where a is coefficient of x, which is 1, then x minus ai raised to n plus 1, minus nth derivative of this is minus 1 raised to n into n factorial, again 1 raised to n, that is 1 upon x plus ai raised to n plus 1. Okay, so if you take this minus 1 raised to n into n factorial out, you will have minus 1 raised to n into n factorial upon 2ai into bracket 1 upon x minus ai raised to n plus 1 minus 1 upon x plus ai raised to n plus 1. Okay. Then there is a substitution for this complex number. This is complex number. X plus ai is a complex number. So you can write it in terms of a modulus and argument. Okay. So x plus ai is equal to r into cos theta plus iota sin theta. So obviously its conjugate will be x minus ai, which can be written as r into cos theta minus I sin theta. Okay. So if you compare real and imaginary part, you will have x is equal to r cos theta, that is real part, and imaginary part is a, which is equal to r sin theta. Okay. And theta is tan inverse a by x. Tan inverse a by x. Okay. Up to this step, any doubt? Yes. Up to this step, any doubt?
No, sir.
No, sir.
Okay.
No, sir.
All right. Fine. So let us substitute this complex number in terms of modulus and argument. So x minus ai is r into cos theta minus I sin theta. So raised to n plus 1. So r raised to n plus 1 is there. Okay. So 1 upon cos theta minus I sin theta raised to n plus 1 minus this x plus ai raised to n plus 1, so which is r into cos theta plus I sin theta raised to n plus 1. So r raised to n plus 1 we can take out. So we'll have this term cos theta plus I sin theta raised to n plus 1. Can you tell me next immediate step? Anybody?
Sir, can you scroll up a little bit?
Fine.
A little more, sir. Yes, sir. 1 minute, sir. Okay, sir. Done.
Yes, anybody? Can you tell me what should be the next step?
Sir, we
E
can use
raised to I theta.
Yeah, e raised to I theta. Okay.
or De Moivre's theorem.
De Moivre's theorem. Okay, good. Do you remember that? What was the statement
Yes,
for
sir.
De Moivre's theorem?
The power will come beside theta.
Yeah. So cos theta plus iota sin theta raised to n or raised to any power is equal to cos n theta plus iota sin n theta. Okay. And this is true for its conjugate also. So cos theta minus iota sin theta raised to n is equal to cos n theta minus iota sin n theta. That was the statement for de Moivre's theorem, which you have studied in 12th. All right, so we'll use that. So this n plus 1 will come with angle. So this minus 1 raised to n factorial 2ai r raised to n plus 1 as it is. Then 1 upon cos of n plus 1 theta minus iota sine of n plus 1 theta. Then minus this 1 upon cos of n plus 1 theta plus iota sine n plus 1 theta. Okay. Now do this cross multiplication. What it will be? Cos n plus 1 theta plus iota sine n plus 1 theta minus cos of n plus 1 theta minus minus become plus iota sine n plus 1 theta. What will be denominator? A minus b, a plus b.
Yes, sir. But beach में there will be plus because iota, so 1.
Yeah, okay. So denominator will be 1. A minus b, a plus b. So it is a square minus b square. But there is iota in between, so that I square becomes minus 1. So minus minus become plus. So denominator will be cos square n plus 1 theta plus iota plus sine square n plus 1 theta, which is 1. And what will be numerator? This cosine will get cancelled. This is plus and this cosine will be minus. And sine is 2 times iota sine of n plus 1 theta. Just let me know, is this calculation clear to everyone? This whole bracket is 2 iota sine of n plus 1 theta. Is that fine?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. What about others? Any doubt in that step?
No, sir.
No, sir.
Yes, sir.
Okay. Fine. So 2 iota will get cancelled. So what we'll have is minus 1 raised to n factorial a r raised to n plus 1 sine of n plus 1 theta. Okay. Now what is r? What we know is if you compare imaginary part, a is equal to r sine theta. So r will be a upon sine theta. So substitute that value of r here. So minus 1 raised to n factorial sine of n plus 1 theta upon a into a raised to n plus 1 upon sine raised to n plus 1 theta. Okay. So if you take this sine raised to n plus 1 in numerator, so yn is equal to minus 1 raised to n into n factorial sine of n plus 1 theta sine raised to n plus 1 theta upon a raised to n plus 2. This is n plus 1 plus 1 more a. So a raised to n plus 2, where theta is tan inverse a by x. So this is the derivation for nth derivative of 1 upon x square plus a square. Any doubt? Any doubt? Please respond.
No, sir.
No,
No,
sir.
sir.
Have you copied it? Have you copied it?
Copying, sir. Copying, sir.
Okay. Do you want me to scroll up? Yes.
Sir, we
Do
have
you
to
want-
remember this direct formula.
Yeah. We are going to use this many times, this last formula.
So we have to just remember this formula. Like,
Yes.
sir, what will come in Thursday's tutorial?
Whatever we'll cover till Thursday ka morning lecture.
No,
on
sir,
nth
matrix
derivative.
matrix
No.
part will.
Matrices. No, won't be there. That won't be there.
Okay, sir.
Yeah.
Sir, you gave me that PDF of questions.
Yeah.
In that n derivative solutions are not there, sir.
Okay. Anyway, I'll see. You can find out solutions, no?
No, sir, like I did questions, but I was not sure that whether answer was correct or not.
Okay. Correct or not? Okay.
So can you scroll up a bit for a second?
Yeah. Fine. Is it fine?
Yes, sir, done.
Okay. Can you go to next problem?
Yes, sir.
So on next page, you can see that if y is tan inverse x by a, then find its nth derivative. Any smart answer for this? Anyone?
Sir, the n minus 1th derivative will be the n derivative of the equation we just saw.
Okay, 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 good, very good. So, because you can see that its first derivative is 1 upon x by 1 upon 1 plus x by a bracket square. After simplifying, you will get a upon x square plus a square, isn't it? Is first derivative okay?
Yes,
It is
sir.
a upon x square plus a square. Yes?
Yes.
Okay, fine.
Yes, sir.
So y1 is equal to, you can take this a out, 1 upon x square plus a square. So differentiating y n times is same as differentiating y1 n minus 1 times, isn't it?
Yes, sir.
Okay. So differentiate this y1 n minus 1 times. So total derivatives is n minus 1 plus 1. So y n, a as it is. What is n minus 1 derivative? What is n minus 1 derivative of 1 upon x square plus a square? Yes. What will be n minus 1 derivative of this thing? In place of n, substitute n minus 1. So what it will be? Minus 1 raised to n minus 1 into n minus 1 factorial sine of n theta into sine raised to n theta upon a raised to n plus 1. Is that clear to everyone?
Yes, sir.
Yes, sir.
Okay. Wherever there is n, you substitute it by n minus 1. So yn is equal to a into minus 1 raised to n minus 1, n minus 1 factorial, sine n theta, sine raised to n theta upon a raised to n plus 1. Okay. So this a will get cancelled. You will have power of a as n. Okay. So remember that you need to mention this theta always. Theta is tan inverse a by x. Okay, because in derivation itself, we have seen that theta is tan inverse a by x always. So for tan inverse x by a, nth derivative is minus 1 raised to n minus 1, n minus 1 factorial, sine n theta, sine raised to n theta upon a raised to n, where theta is tan inverse a by x. This is second formula which you are going to remember. So just note it down.
Sir, scroll down, please.
You mean scroll up?
No, sir, I mean scroll down.
Fine.
Yes, sir, thank you.
Sir,
Yes.
so can you show the previous page for just a second?
Okay. Done. Copied.
Can you show for the n-1th derivative?
Yes, thank you, sir.
Yes. Okay.
Sir, little bit more, the denominator is not showing. Yes, sir.
Okay. Can you go
Done,
ahead?
sir. Done, sir.
Yeah. Okay. So using this, we are going to simplify few problems, and then we are going to find nth derivative. All right. So if y is equal to tan inverse under root 1 minus x square minus 1 upon x, then find its nth derivative. Okay, so obviously looking at this y, you can't think of y1, y2, y3 and then generalize yn, isn't it? It won't be that much easy, right? Right?
Yes, sir.
So you need to simplify this y, okay? You should have simplified expression for this y. So can you tell me the substitution? So that this tan inverse will get uh, sort of diminish.
X should be tan of
Yes.
some angle.
Okay, so x is equal to tan phi. Now you can see that intentionally there is phi, not theta. Okay, and I'll tell you why I have not used theta. So if you substitute x is equal to tan phi, so what will happen? 1 plus tan square phi minus 1 upon x. So 1 plus tan square phi is sec square phi. Under root it will become sec. So sec phi minus 1 upon tan phi. So sec phi is 1 upon cos. So it will become 1 minus cos phi upon sin phi, because that cos phi will get cancelled from numerator and denominator. So tan inverse 1 minus cos phi upon sin phi. So 1 minus cos phi is 2 sin square phi by 2, and sin phi is 2 sin phi by 2 cos phi by 2. So one sin will get cancelled and 2 will get cancelled. So in numerator you will have sin phi by 2. divided by cos phi by 2, which is tan phi by 2. Okay. So tan inverse tan phi by 2 becomes phi by 2. So phi is tan inverse x. Okay. Phi is tan inverse x. So 1 by 2 tan inverse x is the simplified expression for y. Right? Then 1 by 2 you can say it as it is, or you can take as it is, and nth derivative of tan inverse x we just now mentioned, which is minus 1 raised to n minus 1, n minus 1 factorial sine n theta, sine raised to n theta, okay, upon 1 raised to n, okay, because tan inverse x by a ka derivation we have seen. Here a is 1, so upon 1 raised to n, that becomes 1, where theta is tan inverse a by x. A is 1, so tan inverse 1 by x. Okay, so is that clear that I have not used theta here? Okay,
Yes, sir.
can you tell me the reason? Can you tell me the reason?
Because finally, when we write the general formula, the theta there is different than this
Yeah.
substitution.
Okay, good, very good. See, this theta is different than this angle. So you need to use another notation for this angle. Okay. So otherwise it will be abuse of notation. Any doubt in this solution?
No, sir.
Okay. Have you copied? Can we go ahead?
1 minute, sir. 1 minute.
Okay.
Sir, can you show the final result?
Yeah.
Can you explain the final statement?
This yn.
Yes, sir.
Okay. So up to this step, everything is fine.
Yes, sir.
Okay. Now just observe, if y is tan inverse x by a, then yn is minus 1 raised to n minus 1, n minus 1 factorial sine n theta, sine raised to n theta upon a raised to n. Okay. Now in our case, a is 1, isn't it?
Yes, sir.
So the nth derivative will be that 1 by 2 is there in multiplication. Okay, tan inverse x upon 2. So take that 1 by 2 out. Then nth derivative of tan inverse x. What is it? Minus 1 raised to n minus 1, n minus 1 factorial sine n theta, sine raised to n theta upon 1 raised to n. Right? Because a is 1 in our case. Fine?
Yes, sir.
So theta is equal to tan inverse 1 by x. Okay? Can you go ahead?
Yes, sir.
Yes, sir.
So can you just try this? Obviously it is simple. So find nth derivative of y is equal to cos inverse x minus 1 by x divided by x plus 1 by x. Okay, this x inverse is nothing but 1 by x. So if you simplify this, it will become cos inverse x square minus 1 upon x square plus 1. So our target is to get rid of this cos inverse. That means inside this bracket, we should have cos, so that cos inverse and cos will be identity map. So x is equal to tan phi will suffice the requirement. So x is equal to tan phi will give us y is equal to cos inverse tan square phi minus 1 upon tan square phi plus 1, which is nothing but minus of cos of 2 phi. Okay, because this is minus 1. Okay, it is 1 minus tan square phi. No, in formula of cos 2 phi, it is 1 minus tan square phi upon 1 plus tan square phi. So this is minus of cos of 2 phi, so which you can write as cos of pi plus 2 phi. Okay, cos of pi plus 2 phi. So that becomes pi plus 2 phi. So simplified expression for y is pi plus 2 phi. Now phi is nothing but, from this, phi is nothing but tan inverse x. So y is equal to pi plus 2 tan inverse x. So again, if you take nth derivative of this expression, derivative of pi is 0, then 2 times nth derivative of tan inverse x, which is minus 1 raised to n minus 1 into n minus 1 factorial sine raised to n theta sine n theta, where theta is tan inverse a by x, where a is 1. Okay, any doubt?
No, sir.
Okay, what about others? Any doubt in this example?
No, sir.
No, sir.
Okay. Have you copied?
Sir, wait a minute.
Okay. Done?
Yes, sir, done.
Okay. So as a homework, there are 3 problems on similar line, and substitutions are very clear actually. Okay. Can you tell me what will be substitution in each of the case? Anybody?
Sir, tan theta.
tan theta. Again, you are using theta. Please do not use
Tan
theta
phi.
there. Yeah, tan of
Tan
some,
phi.
yeah, other angle.
Yeah, but then if we
Because
by mistake use theta out of habit, we can later write the general formula in terms of phi, right?
yeah, that is fine. Okay, so just note this down, 3 example. Then we'll go ahead.
So the first one is tan inverse 2x divided by 1 minus x square, right?
I really don't know what she has written. It is plus or minus. Let me check.
If it is minus, then sine theta will do, sine phi.
Yes, so it should be minus.
No, it could be minus, and if it is minus, then it could be sine phi in terms of substitution.
Then it will be plus. Because if you write x is equal to sine phi, then phi is sine
Tan.
inverse x.
Yes.
Phi is sine inverse x. If you take minus, but you don't know nth derivative of sine inverse x, isn't
Right,
it?
huh? Yes.
So it is plus.
Sir, what to substitute for second and third?
There is no other substitution than x is equal to tan phi. Okay. See, this one you can write as tan pi by 4. X is tan phi. So tan pi by 4 plus tan phi upon tan pi by 4 minus tan phi. Fine. Tan A plus tan B upon 1 minus tan A tan B. Yeah. Please respond.
Yes, sir.
I repeat, this one you can write as tan pi by 4 plus x is tan phi upon 1 minus tan pi by 4 into tan phi. So tan A plus tan B upon 1 minus tan A tan B का formula you can use. So that
So
this,
tan A minus B. Tan A plus B, sorry.
yeah.
Okay, sir.
Fine. So we'll go ahead now. Now, up till now, we were finding nth derivative of a single function. Okay. Say sin x, cos x, then e raised to x, log x, or tan inverse x, and so on. Okay. But if you have something like x cube sine 3x, x cube sine 3x, then how to find its nth derivative, or how to find its 50th derivative? That is the question, which was solved by Leibniz theorem. Um, and the statement is, if you have product of two functions, so y is equal to u into v, then its nth derivative is taken as yn is equal to nc0 nth derivative of u into v as it is, plus nc1 n minus 1 derivative of u into first derivative of v, plus nc2 n minus 2 derivative of u into second derivative of v, and so on, ncn u as it is nth derivative of v. Okay, where nc are the binomial coefficient. Okay, so just write it down. Write down this statement. if y is product of two functions u into v, then its nth derivative is taken as yn is equal to nc0 un v plus nc1 un minus 1 v1 plus nc2 un minus 2 v2 and so on ncn u vn. Okay, where ncr are the binomial coefficients. What is value of nc0? After this statement, if you don't know values of binomial coefficient, you should write it. What is nc0?
1.
1. What is nc1?
N.
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 And what is nc2? N into n minus 1 upon 2 factorial. Write down n into n minus 1 upon 2 factorial. nc3 is n into n minus 1 into n minus 2 upon 3 factorial. And so on.
Sir, can you repeat?
Okay. nc0 is 1. nc1 is n. nc2 is n into n minus 1 upon 2 factorial. nc3 is n into n minus 1 into n minus 2, whole thing divided by 3 factorial, and so on. Okay, where suffixes denotes order of derivative, that is known to everyone. Done?
Yes, sir.
This theorem is very important, huh? Because you can see the problems based on Leibniz theorem are interesting. So there is important note. Choice of u and v is important. So that function is chosen as v whose successive derivative vanishes earlier. Okay. The function should be chosen as v whose successive derivative vanishes earlier. Meaning hereby, if we have function e raised to 3x into x cube, e raised to 3x into x cube. So can you tell me what is your u and v? Anybody?
Sir, x cube v.
Okay, and u will be e raised to 3x. Isn't it?
Yes, sir.
Okay. What about others?
Yes, sir.
Yes, sir.
Okay, okay. And the function should be taken as u whose nth derivative is known to you. All right. So first is find nth derivative of x square e raised to x. Okay, let us quickly find out its nth derivative. So tell me choices for u and v. What
For
should be
v
your u?
x square. V x square.
Okay, and u is e raised to x. Okay, so find out their successive derivatives. So nth derivative of e raised to x is a raised to n e raised to x. Then first derivative of v is 2x. And n minus 1 derivative of u is a raised to n minus 1 e raised to x. Then V2 is 2. N minus 2 is un minus 2 is a raised to n minus 2 e raised to x, and V3 is 0. Okay. So what we know is yn is equal to nc0, that is 1 unv, plus nc1 un minus 1 v1, plus nc2 un minus 2 v2. And what will be next step or next term? nc3 un minus 3 v3. Okay, this next step. But v3 is 0, so v3 onwards everything will be 0, isn't it?
Yes, sir.
So just substitute these values. Yn is equal to un is a raised to n e raised to x into v is x square, plus nc1 is n un minus 1. So n minus 1 derivative is a raised to n minus 1 e raised to x into v1. So v1 is 2x, plus nc2, that is n into n minus 1 upon 2 factorial, n minus 2 derivative of u. So that is a raised to n minus 2 e raised to x into v2. v2 is 2. Okay. And next term is 0, obviously, because it contains v3. So only these terms will survive. You need to simplify it. So a raised to n e raised to x is common everywhere, so you can take it out. So what will remain is x square plus 2nx upon a plus n into n minus 1 upon a square. All right. Any doubt here?
No, sir.
No, sir.
Sir, can you show the previous page where the statements were written?
All right. Fine.
Sir, no, the last para, just the last para after this. Yes, sir, thank you.
Can you try this second, x cube into cos x? Or do you want to copy this first one? Please respond.
Sir, we are copying.
Okay. Just write it fast.
So for x cube into cos x, we will take v as x cube and cos x as u.
Yeah, correct.
And for cos x, we will put that formula cos bx plus c wala formula.
Right, right, right.
Can you show the next question?
It was x cube into cos x. Find nth derivative of x cube into cos x. Of course, there is no mention of using Leibniz theorem, but one should understand that it is product of two functions, so you have to use the Leibniz theorem. Okay, and here is the solution. So let us quickly go through it and we'll stop there. So x cube whose fourth derivative is 0. Therefore, we take it as v, and u is cos x. So nth derivative of cos x is cos of x plus n pi by 2. First derivative of v is 3x square. N minus 1 derivative of u is cos of x plus n minus 1 pi by 2. Second derivative of v is 6x. N minus 2 derivative of u is cos of x plus n minus 2 pi upon 2. Third derivative of v is 6. Okay, and fourth derivative is obviously 0, so no need to write it. So by Leibniz theorem, nth derivative is nc0, which is 1 unv plus n into un minus 1 v1 plus n into n minus 1 upon 2 factorial un minus 2 v2 plus n into n minus 1 into n minus 2 upon 3 factorial un minus 3 v3, and next term is 0 because it contains v4, and v4 is 0, fourth derivative of v. So just simply substitute this derivative, okay, and simplify as much as you can. All right. So with this, we'll stop here today. May I stop sharing? Or you are copying? Please respond.
So can you share today's PDF?
Okay, fine.
Thank you, sir. Thank you, sir.
So may I stop sharing this PDF now? Okay.
Yes, sir.
Yes, sir.
All right.
Yes, sir.
Before leaving this meeting, please write down your name and roll number in chat box. So I will copy it. Okay, and then you can leave. Thank you.
Thank you, sir. Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you.
Thank you, sir.
Sir.